when you have 1 minus like cosine squared x, and you make this substitution, I saw people rewriting this as like 1 minus cosine x like squared or something like that. These are not the same expressions. All right? So don't confuse these two. This one, if you FOILed that out, that would not equal this. Here the squared is only on the cosine, here the squared is on both terms, so you have to FOIL. Yes?
What did sine squared turn into 1/2 1 minus cosine squared?
Very good. The question here is, could we use that half angle identity to turn that into the 1/2 and then the 1 minus the cosine 2x, right? Couldn't we? Yes, we could, but it won't help in this problem because it's an odd power. If I change that to even, that's exactly what we'll use. But if you see odd, this is the standard approach. The real problem if you do that, just to show you, the real problem that you would run into is this. Right? That's what you would have. The problem is this is cosine 2x and this is sine x. And now you can't even relate these two. You can't say that's my u and this is my du because the derivative of that is not this. They're no longer connected because you've doubled the angle. Understand?
Yeah.
Okay. So that's why we will avoid that for odd powers. Odd's the big thing right now. Okay, odd. All right, so let's make this substitution. Du is going to be negative sine x dx, which we almost have. We're off by sine, so negative du is sine x dx. And now we're going to rewrite the integral. What does my new integral become? Integral 1 minus u squared, right? Because cosine is squared, so 1 minus u squared. Sine x dx is negative du. Pop that negative out, du out here. And can you integrate that? I hope so. If you can't, you're going to have a long weekend if you're going to get up to speed, right? Antiderivative of 1 with respect to u is u, and then antiderivative of this, 1/3 u cubed, right? And then we have a negative in front of all of it. So I'll leave the negative out there. Antiderivative of 1 is u. Antiderivative of that is negative 1/3 u cubed plus c. Y'all get that? Let's distribute the negative through. And finally, replace u with cosine x. So my final answer, I'll put it up here next to this. My final answer would be negative cosine x plus 1/3 cosine x cubed, right? So I put that little 3 right here to let everyone know I'm cubing that, and then plus c. I claim that if we differentiate that, we will get sine cubed x. Questions, comments, concerns, complaints? Yeah, I plan on doing something like this on the test, which I'll tell you what problems you can look at from the homework if you want to start getting, like if you want to focus on only on the problems I would ask. I'll tell you at the end of class what to look at. And then, of course, on Tuesday, I'll entertain any questions if you'd like to see a couple more of these done. All right, let's turn up the heat a little bit here, and let's change that to something like 5th power. You could go sine squared, and then that sine, right? You could do that. Main thing I want you to see is if you see sine to an odd power, peel one sine off. I mean, that you need to do, all right? So let's just do that first. This would be sine to the 4th x times sine x dx, right? Now, the last problem we had, we went right now and we converted, this was a sine squared, right? So we went right to 1 minus cosine squared.
It's the same thing.
It is the same, but it's not going to be 1 minus cosine to the fourth, though, right? We actually have to look at this as being sine squared x squared, which is the same thing you're saying, all right? And now I'm going to turn the original sine squared that's in that parentheses into the 1 minus cosine squared. And then I'll say squared, yeah. So integral 1 minus cosine squared x squared sine x dx. And now do exactly the same thing we just did, a basic U substitution. Why am I doing a basic U substitution? Because I see something and its derivative, right? I see something and its derivative. So my U sub here is cosine x again. The derivative of that, I already know is negative sine x, but I'll take care of that negative now. So when I rewrite this integral, what have I got? Put the negative now outside? Okay, negative out here. 1 minus u squared. That quantity squared times du. And will you be able to integrate that? How? You can't just do like each one individually, right? Not these two. You have to take care of that. So just expand it all out, right? Just square that thing. If I square it, I'm going to get 1 minus 2u squared plus u to the fourth du. So I did 1 minus u squared times 1 minus u squared, and then I played that little game we play and put it all together, and that's what I got, right? Now can you integrate that? Just each one by one. I feel like calling on someone. Let's see who has not been called on. I'm going to also pass around your quizzes from last time. So please just grab yours out of this stack and then pass them around. I sent an email out to the people in the class that have a quiz average below a 60 on the first two quizzes. Hopefully you checked your email. It was me just kind of saying, hey, I'm a little concerned about you right now. If you haven't been able to keep up with the quizzes, then, test is a week away. Hope everything's okay. Let's see here. Somehow I missed marking some people here. All right, how about, is Brian here today? Brian B, right? Brian Bendula. All right. Brian, antiderivative here?
Antiderivative of 1 with respect to u
Mm-hmm.
is
U, okay. What do you want me to do with that negative? Do you want me to take care of it now or just keep it on the outside the whole time?
keep it outside.
Keep it outside? Okay, so I'm going to have to make sure I account for that. I'm going to put negative, I'll put negative 1, and then you just give me the antiderivative. Go ahead. U.
Then the antiderivative of 2 to the u squared is u cubed
Uh-huh.
and 2 divided by 3 u cubed.
Okay, good. And then,
And the next one would be u fifth,
uh-huh,
1 over 5.
out front. Okay. That's it, right? Done. All right, plus C. Everyone agree? All right, so am I done, or do I need to keep distribute the negative now? All right, how about negative u plus 2/3 u cubed minus 1/5 u to the 5th plus c. Now are we done, Brian?
Or no.
Okay, good. What do I still need to do?
2 times the u
Okay, what was u?
cosine x.
Cosine x. Then we'll be done, right? Okay, so we've got negative cosine x plus 2/3. And when I write cosine x and I cube it, I put the 3 right there. Why don't we write it like this? That's confusing, isn't it? Am I cubing the x or am I cubing the whole thing, right? So we put the 3 right there to mean the whole thing. So this is actually that. Those two are the same. This is not. That's not equal to that. All right, minus 1/5 cosine to the 5th x plus c. There we go. Good.
That's more simple than integration by.
You like that? It's a little cleaner than integration by parts so far, right? So far. Okay. I said that this section is like this section is like 2 parts. The first part is pretty clean, pretty straightforward. There are going to be some little hiccup spots on it. The second part is going to feel like we're back into something like integration by parts. It's going to be exciting, for lack of a better word. I'm going to try and squeeze 2 more examples in. Okay, what's the difference here? It's even. It's even, right? When it's even, you will not peel off a sign. What you will do is you will use that power reducing or the half angle identity. So this is the one we're using when you see even up here. So this goes straight to the formula, doesn't it? This is just 1/2 parentheses 1 minus cosine 2x dx, right? That's it. What can I do there? Take the 1/2 out. And then I have 2 terms, 1 minus cosine 2x dx. And let's see. Where's Garrett? Garrett? No? Garrett? Okay, Garrett, you're up. Putting you on the spot here. Guess what I want to know, Garrett, is how you're going to handle this. What you're going to do with that. Each one individually? Yeah, it's no problem, right? Just do it, right?